So I think we've got folks joining. So first and foremost, Matt Stamper, president here at the ISACA San Diego chapter. Thrilled to be here along with Dave Tuckman, and I also see a number of other members of our board also joining. So Rich Gann, Tim, Con, and numbers there. I'm just scrolling this very quickly. But first and foremost, on behalf of our San Diego ISACA chapter, welcome. Dave has got a quick announcement as it relates to our chapter's LinkedIn site. So Dave, I'll hand it off to you for just a moment.
Sure, and I just put the link in there, and what we wanted to share with everybody is this link here is the business page on LinkedIn for the chapter. There was also a private group in LinkedIn, and we're going to be phasing that out just because this one can be publicly available for everybody. So we just want to get the link out, let you know to follow this one for updates moving forward. Excellent.
Another thing we obviously want to extend is if you are a student at a university and you're interested in cybersecurity, to participation in a webinar like today's, always welcome. We will sponsor student memberships for students in this region into our chapter. And we really want to do everything we can to help foment and support that next generation of IT security, audit, governance, and risk professionals. The last thing, obviously, is if you're at an organization and you're trying to hire people, our isaca-sd.org website, we are always ready, willing, and able to post security, governance, risk management, IT audit type positions on that site, and certainly try to do our best to help promote that. We want to make sure everybody that wants to find a position finds one, and those companies that are looking for good, high quality talent are able to find it as well. The topic today could not be more timely. Application security, which is a very specialized domain, is frankly how a lot of major organizations are getting popped. And how we think about application security, very bluntly, we need to uplift our game. We really have to start thinking about application security in a very distinct way other than just, you know, we put a web application firewall in front of our environment, therefore we're secure. I am absolutely thrilled to be joined by my friend and former colleague at Gartner, Michael, to come in here and talk to us a little bit about kind of the state of application security in a very detailed but an extraordinarily important area, application programming interface security. So without further ado, Michael, the floor is yours. We'll ask people if you've got questions that you want to posit, throw them into either the chat or the Q&A, and one way or another, we'll make sure we get those addressed. Michael, welcome on behalf of our San Diego chapter.
Awesome. Thanks, Matt. It's really good to be here. It's good to see you again, virtually. Hopefully one of these days we'll see each other in person again. Exactly. So yeah, Matt and I did work together for some time at Gartner. I covered application security within the Gartner for Technical Professionals division. So many of those conversations got very in-depth. I'd say towards my latter days there, I was covering a lot of Kubernetes security because a lot of organizations are kind of getting into that space with infrastructure. Container platform, but also API security. That's kind of filled most of my inquiry calls and research. So long story short, I'm actually a technical evangelist with Salt Security now. I still do a lot of the same work, to be quite honest. I still research in this space and I get to talk about it. So please, if you have any questions, definitely put them in chat. You know, if you think of something after today, my contact info is going to be in the end of the presentation too. So please always reach out. And I love talking about these, both of these topics, honestly. So really quickly, right? I'd imagine, you know, some of you are maybe in the application space, but I'd imagine everybody's kind of heard of DevOps, right? It's kind of been beaten into our heads for years now. It's where many organizations want to go, right? DevOps practices are those things that allow you to kind of build and release much faster. Crosses a lot of IT domains. Inevitably, it's a lot of automation, right? And if you're approaching it from the security angle, it's very much about getting security integrated and automated within DevOps practices and tool chains. There's a lot to this, right? I could spend hours just talking about DevSecOps, but let's kind of talk about what one piece that's typically means for organizations is secure build pipelines. You know, most of the calls when I was talking to organizations of all sizes and maturities, you'd probably be surprised, you know, who was asking what when. Honestly, the questions became very common. But everybody's kind of working from, we have these CI/CD processes. These are our build pipelines. The reality is most of the time there's multiple build pipelines, right? Very rarely can you get to the position of one CI/CD pipeline. It's usually many. It's usually a factor of the languages you're working with. And I mentioned Kubernetes, right? You know, those things you start working with infrastructure as code and infrastructure automation, that becomes yet another pipeline. So it's tricky, right? It kind of looks simple at face value, right? That's kind of how it started. How it's going for most organizations, it is a little bit of a train wreck, right? It's never a simple conversation. You know, Matt can attest to this. Our inquiry calls, they were an hour. And many times I would meet with organizations. It might be multiple series of calls, right? You didn't always arrive at an answer within that 1 hour. And that might just be one build pipeline, right? And now you're talking about multiple teams and culture within the organizations, different tech stacks. It's a lot, right? So we would talk about the need for automation and tooling that you could plug into build pipelines, but then reality inevitably hits, right? Things can go off the rails very quickly. So you know, the issue is it leaves gaps in application security, but also API security. Very quickly, our agenda for today, I'm going to cover some current application and API security trends. I'm going to talk through, you know, what are we doing today to protect apps and APIs for the most part? How do those things maybe not cover us fully? And then where do we go from here? You know, basically recommendations. So current app and API security trends. You know, I'd be curious where everybody is in their API maturity. You know, are you building APIs as products? You know, maybe we can get to that in Q&A. But you know, typically what happens is organizations are in different stages of the learning curve, but also API adoption. The reality is, if you are acquiring software or just consuming software, like even if it's just SaaS-based API, SaaS-based applications, those things are actually powered by APIs. That's how cloud services are building, because it allows them to innovate faster, right, and deliver faster, and then, you know, provide you the data, those pieces of data that you need. So it's the number of APIs are essentially exploding, right? If you weren't aware, they are there, and it can even be in commercial packages that you install in your environment. And actually, we just saw that pretty recently with the Exchange server hacks, right? A lot of practitioners might think of, well, it's an email server, you know, that's just something sitting in a data center, uses APIs, and one of the APIs was the initial attack vector for that supply chain attack. It was pretty brutal, right? From using that web API, you could then pivot, kind of get into the server operating system and start to do things much more maliciously. So kind of a nightmare scenario with you know, very, very large blast radius. You could kind of own an entire network. So APIs are almost always that's the thing, right? That's almost always the entry point, but often that's actually the product or the app. App design patterns have really evolved, right? We are still building monoliths in some cases, but a lot of organizations are really all aboard microservices architecture. Without going too deep in the weeds, it's really just, you know, monolith does a lot of things. You know, you can kind of envision just some giant thing. Maybe it's hard to understand, right? Maybe somebody else built it. But with microservices, it does one thing, right? It should, by definition, only do one function, right? And you can start to piece things out, which actually has a lot of benefits for how you build infrastructure and construct apps and reuse functions. So there's a lot of business benefit to that. That's why organizations are kind of all aboard that. Teams are distributed, right? That's a reality. Most organizations do outsource app development. And we see this a lot also with digital supply chains, right? it's rare that you own all the code. Somebody else is likely building pieces of it, or maybe the entire thing. And there's been a lot of push for shift left, right? I made that joke about secure build pipelines. There's reasons to do that, right? Because as security practitioners, we've kind of been told it's very expensive to fix things at the tail end of the SDLC. So we need to kind of get security earlier into design and development stages. So it's, you can fix those things much more quickly, save money for the company. So there's benefits to it, but we're going to talk about why that's not enough. A lot of breaches and privacy impacts. I'm not going to go through all these. There's been others, right? Peloton, Experian, LinkedIn, which is debatable. If you're Microsoft, it's not a breach, which I'd love to talk about that one if we had another hour. But it's not stopping, right? Because companies build APIs to exchange and expose data, and attackers know that, right? So they're not going to stop. And the way we approach it is with a lot of kind of traditional runtime security mechanisms, which don't always work. And we're going to talk about this also in a bit. And they actually start to impede API performance as well, particularly if you get into the world of microservices architecture. So a lot of contributing factors that are just kind of making this a really big problem. Organizations are definitely in different stages of awareness. It might not even know that an attack, is a result of an API, but it's certainly improving. One topic in particular, I would love to, this could be an hour-long discussion, but zero trust is often pitched as the cure-all, right? And it has benefit, right? If you're talking about the philosophy of zero trust, it's kind of the principle of least privilege, right? That's security 101, like only grant access that is absolutely necessary to perform your function. And with zero trust, it's much more the environment is not necessarily trustworthy, right? Somebody might compromise an asset, so you have to continuously be, verifying, trust the entity, but continuously verify are they entitled to this resource. It's not a specific piece of technology, right? It's a concept first and foremost. It can map to multiple technologies. I saw a lot personally on the microsegmentation front. If you're in the world of network security, maybe software-defined perimeter is your world, or zero trust network access. Ultimately, these are network access control mechanisms, right? Unfortunately, they sometimes get pitched as app protection, but it's really about kind of controlling that perimeter, right? And perimeter shift as you move infrastructure to the cloud. So it's, these technologies are kind of built for those new worlds, but they're protecting different things. And very rarely do they go down to app layer, let alone kind of understand API context. So this is a big pitfall. I'd say some of our customers at Salt use our platform to feed their network access control mechanisms. It could be microsegmentation technologies or network load balancers, but it's not one piece of technology they would go out and procure. We shifted left too far, to be quite honest. Many of the calls I took at Gartner were on security testing. How do I do this? I see Matt laughing. Should we do static analysis? Should we do dynamic? Which tool do we need? How do we start? What do we start with? Do we pass fail builds? Like, you name it, it was all the questions, right? Because shift left was kind of, it's going to fix things. We're going to fix all issues pre-production deployment, and then we're not going to get breached, right, or popped. The problem is it kind of went too far, right? I saw many cases where almost all of security was pushed left, right? And it actually started to create friction with development teams, which is the opposite problem, right? Or it's the same problem reinvented. Like, we shifted left to avoid doing all the testing pre-production deployment, spending 2 to 3 weeks. Then you get this lengthy report, and now app dev's got to fix it. Now the problem's kind of shifted where we push all the work on development, expect them to do all the testing and then fix all the things. So it doesn't actually really address the core problems. And quite honestly, a lot of the times when I would take questions on security testing, it was dev teams or QA teams. It might not even be security. So a little eye-opening, but kind of the reality, right? That's how organizations were pushing.
Can I
Yeah,
pause
go
you
ahead, Matt.
here just as it relates to security testing, things of that nature? We had a comment come in from Jeff Sauntry in terms of the kind of the PCI framework, and there's expectations for penetration testing and other things. Would love to get your insights as it relates to that in kind of this context to shifting too far left.
Great question. Let me give my quick answer, and then if we have more time, we can definitely dig in. I think it was specifically the app one. I think it was requirement 6.6 in the DSS, but it, originally it was pretty vague. It would say like you should do testing, security testing, or have an adequate runtime protection in place, which is how a lot of organizations arrived at deploying WAFs. They might do that in passive mode as opposed to active, which is another problem, right? It was to meet compliance as opposed to securing the thing. DSS has kind of evolved where they flesh that out more. Like they'll say, you should test periodically and then test anytime you make changes to that code. And it's like, well, if you're changing code daily, right, as part of your agile development practices and DevOps practices, where do you draw the line, right? So it's you could be testing all day, right? And different types of testing, static analysis and dynamic analysis. I used to get this question a lot. If you are doing those things automated in your build pipelines, do you make that blocking to a production release, right? Because these tools might not even finish in time. So what do you do at that point, right? So it's like a dynamic tester might take days realistically to test an entire application. It's kind of a known problem with pretty much every commercial test tool. So usually my guidance was test asynchronously, like trigger as part of build pipelines if you were at that point. But you might have to kind of make the risk call, like deploy, and but do we have good rollback capability to revert if our desk tool finds things, 24 or 48 hours from now? That's my quickest answer. I would say it's going to depend on a QSA too, like how deep do they dig? For a lot of organizations, they're not even doing security testing yet in their build pipelines. So, a QSA might be satisfied with a vulnerability assessment scan, which is another problem entirely. It's kind of cursory. It doesn't go deep enough, but very common for sure. The other problem with shifting left is engineering of apps tends to be very complex because things are distributed, right? It's rarely one app team that owns everything end to end. And we talked about outsourcing, right? So there might be teams external to the organization. And then there's turnover, right? So you rarely have complete knowledge of an entire system, right? And its architecture. So again, this is a problem. Who does the testing? Who fixes things? And where do you stop, right? You could be testing till the end of days and then the code's changed, right? It really hasn't changed the problem. The other thing that kind of happens, and we're going to talk about this in a bit also, specifically with APIs, is security teams will ask a lot for API documentation, like schema specifications, because that can guide security testing tools and protection mechanisms. The problem is development teams aren't always documenting, right? It's or if they are documenting, they're not documenting fully. And we're going to talk about, why schema generation also isn't a cure-all. You can define an API and use those things to protect the API, but the schema doesn't fully define what does a field contain, right? If it's a string, well, what should that string look like? So there's issues with that also, but security teams will often just kind of revert to this. It's kind of, give me all your documentation and I'll get back to you. But with APIs, they'll ask for the specs. Really, this is kind of summing up my guidance always with, security testing and DevSecOps. It's kind of loaded, right? There's a lot of qualifiers here, but it has to be low touch, right? You don't want to be inhibiting anybody's work streams. These days with DevOps, everything is Git centric. Even, I talked about infrastructure that gets into GitOps workflows. it's all Git version control systems. And it has to be high signal to noise ratio, right? So you don't want a lot of false positives or just findings that just aren't actionable, right? It's not a good use of time. We've really overloaded the application traffic cops, as I like to call them. If you need this bucket of things that organizations front end their apps with. Identity and access management is absolutely critical, right? That's what's going to provide your access control and authentication and authorization. And applications are integrated with them, so you can kind of identify the individual that's trying to access your app or API, and then authorize, are they entitled to access this piece of data or functionality. What we see, with a lot of incidents, I don't believe it's in this presentation, but if you go to our blog, there's a lot of cases of broken object level access or broken function level authorization. And actually, we just launched Salt Labs threat research, which maybe I'll have time to talk about later. Very significant types of issues related to authorization for very big financial institution. Authentication and authorization are incredibly complex, particularly in distributed systems and like these, large ecosystems or supply chains. So it happens all the time, right? So it's security thinking is, well, we're just going to authenticate and authorize, but when you're talking millions of users, potentially thousands of partners, how do you do that at scale? Usually falls over. API gateways are kind of the name of the game for mediating access to APIs, and they work in tandem with IAM mechanisms, right? So the gateway kind of intercepts that request to a given API and hands off to your IAM mechanisms to do that authentication and authorization. And usually it's a component of API management. So something like Apogee, for instance, or Kong, right? There's no shortage of vendors, but organizations get into API management to productize APIs, right? Get more observability over them, set up developer and partner self-service portals, kind of take APIs to that next level, right? The APIs as products. And WAFs, we talked about that. It's a PCI DSS kind of satisfactory control, and used very widely by many organizations. But they're designed to address kind of web application attacks, really not built for API context. WAF vendors have started to circle back and try to build rules for APIs. The problem you run into with APIs is it's very unique business logic. It's really hard to define rules statically that work for all organizations. Another good resource I'd love if everybody took a look at. We're actually going to be doing this twice a year, so there's going to be another report shortly. Is State of API Security. I pulled out some stats that I thought were kind of most interest. One is this, right? We talked about build pipelines and release trains. And sorry, oh, get a drink of water. Sorry, everybody. Getting over a cold, so.
Here, you can use mine.
Thanks, Matt. So yeah, a lot of organizations have actually slowed down application releases, right? So it's like we're going through all this trouble of building build pipelines and trying to accelerate release velocity, but then we're actually halting that, right, because of API security concerns, and a lot of organizations are actually running into that. This is also interesting, right? How do you know which APIs expose sensitive data or personally identifiable information? Documentation from developers, right? I just mentioned that on the other slide. That was actually the top choice. Give me your documentation. That's really not going to tell you if that has sensitive data, right? It's gonna depend if they name the variables the right way. It's really not a good mechanism to detect if it's actually sensitive data. We talked about API management and API gateways that don't necessarily log it, right? It's only going to be that case if it follows very recognizable patterns, right? Like a social security number. Well, what if you have something that's very unique to your organization? How would you know that? And then the others I'd say are probably more realistic, right? They they just don't know, right? And that's a problem, right? If you start thinking about something like GDPR, like if you're concerned about privacy impacts, where do you even start? And we're actually starting to see at Salt that discovery is actually a big business driver for seeking out an API security offering, because GDPR is, you need to know all of your data, right, and how you collect it and share it. So yeah, it's kind of eye-opening, I thought. And this one's also interesting, right? We talked about authentication and authorization as being kind of the go-to as part of identity and access management. In a lot of circles, that is API security. But most of the attacks that customers see are actually against authenticated APIs, right? So if that's the control we're depending on, but yet we're still seeing attacks pass through that, clearly there's a problem, right? We can't rely on just access control. I'm gonna take another drink.
That last statistic there is actually pretty damning, if you think about it. That's inordinately disconcerting.
Yeah, absolutely. And I'm glad you kind of pointed out, Matt, because I even prior to being an analyst with Gartner, I was actually a application security practitioner at Verizon, and I ended up leading their AppSec for quite a bit. I was doing testing, and this was always the argument, right? Well, we're behind SSO, or whatever the vendor was at the time, so we're protected, right? And then they had HTTPS, and then I'd show them how you kind of hijack an authenticated session and then start attacking the app or API. And then it was eye-opening, but it's definitely kind of preached as if you do this, you're protected, but it's really a false sense of security. All right, so let's talk about kind of the approaches to protecting apps and APIs and maybe how they're not working. I talked about those zero trust principles. I know it's more nuanced than this, but like if you do back up and look at it from a high level, it is kind of repurposing that kind of walled castle, right? We need to define the network perimeter. It's shifting, right? It might be microservices in the cloud. But now you need microsegmentation, or your remote connections are distributed, so you need something like zero trust network access. But ultimately, it's about blocking access to that thing. The problem with APIs is connectivity has to be present for APIs to function. If anybody's familiar with firewalls, typically you would open up a port 80 and 443, allow all that traffic in, right? Because those are your web protocols. It's kind of the same for APIs, right? Like that has to be open. You can't block access to that. And if you're talking about open APIs or customer facing APIs, you don't even know the IP address space for them most of the time, right? It's kind of the larger internet. Maybe you can block specific geographical regions, but you really can't rely on IP address, blocking. We talked about that stat, right? Like most of the attacks are occurring against authenticated APIs, and we see the same thing with zero trust, right? You could have microsegmentation, and attack is still going to come through. In the world of APIs, there's a lot of direct API communication, right? So you can't challenge a user, right, for a 2FA token or some login credential, right? We're talking about automation. We're talking about larger ecosystems of integrated things. It's a lot of machine identity, not necessarily user identity. The other problem is metadata about the APIs, like the schema definitions, that those are needed to inform these access controls. In my experience, a lot of the times that's missing, right? Or security teams just don't have access to it. So how do you even define what your microsegmentation policies, if you don't have that expert knowledge about the app and how it should be communicating. These are kind of the operationalizing issues that most companies start to run into. Shift left, right? Let's talk about this one a little deeper. Not all API issues are fixable in code, right? This was kind of one of my biggest pet peeves because developers take a beating on this, to be quite honest, right? Like when there's an application issue, there's a tendency to kind of sling mud towards app dev. The reality is a lot of times things don't exist in the application code, right? You might be relying on a piece of infrastructure to do rate limiting. We talked about identity and access management. You're not doing that in code, right? You're integrating with external systems. Or something's misconfigured, right? If you look at the OWASP API top 10, not many of them are actually specific to application code, right? Which is why it's really difficult for a lot of vendors to say they cover the top 10 because they're maybe too focused on testing, right? Or schema analysis. You have to be looking at a lot of different types of things to say you protect APIs holistically. We actually talked a little bit about static and dynamic analysis, and we can certainly circle back if we have more time. I talked about those build pipelines, right? How they get really complex, and timing, right? What are my release windows? So organizations usually make compromises like, well, let's tune down the scan. Let's search for less things. Maybe we only search for critical or high types of issues, only fail builds on that. So you're sacrificing kind of depth of testing for speed of testing, right? So there's always those trade-offs. The biggest problem though is logic flaws are out of scope for essentially every scanner. They just can't do it because to detect a business logic flaw, unless you're a human looking at all of this, you're not going to detect it unless you're actually looking at traffic in runtime and analyzing those behaviors. It's kind of a form of UBA in a sense, right? I need to gather all this traffic, but very specifically API traffic to what is the baseline, right? And then when things deviate from that, that's likely a sign of abuse. So solutions that really focus on that left side are missing a lot. You just can't find the logic flaws. We do talk about API security strategy. Runtime protection is definitely, if you're going to do anything, that's kind of the better place to start. Honestly, build pipeline testing is incredibly difficult to pull off if you even have budget for it. So I would often stress, if all you can get is a WAF, go for it, right? But if you have APIs, certainly look at something like what we have at Salt Security. And then fast detection and attack detection and response, right? This system needs to be able to detect abuses against APIs, but then also integrate with whatever you're using on the SecOps side of things, right? Typically, that would be some SIM like Splunk. Maybe you're doing some cool SOAR stuff, but when you find an API abuse, who are you coordinating with to kind of mitigate the issue, stop the bleeding, and then get the right parties involved?
When you look at some of these risk factors, how many of these are effectively automated efforts by an adversary? In other words, they're running tools against your tools or your APIs versus an individual or a group of individuals kind of manually trying to address things. So kind of that machine to machine versus machine versus skilled adversary.
I would say it's going to depend on the threat actor. It's sometimes you see like nation state sponsored attacks where they do distribute, but it doesn't take much like for one individual to just start scripting things, right? I mean, maybe they're really proficient at Python scripting. There's a lot of headless browsers. You can write curl commands. There's a lot of intercepting proxy tools. And actually, I do another presentation on like attacker methodology, which is really interesting, right? Because it's like, well, how do attackers perpetuate these things? You don't need a lot, right? You can kind of do it with free tools, and you don't need a lot of manpower either. But if you have manpower as an attacker, it's kind of game over very quickly, right? Because they can coordinate very effectively. Typically, things start with reconnaissance, right? They're going to start trying to passively collect data about a target, probe those APIs. Those are things we look for in the SALT API protection platform. But it's really hard to unearth those signals unless you're kind of purpose built for it. Hopefully that answers the question, Matt. I've seen both, right? But I'd say more commonly, it's kind of smaller handfuls of individuals that might be doing these things.
Excellent. No, thank you very much.
Yeah, the one I would say where that definitely gets crazy is kind of the supply chain attacks, because they are very complex attack chains, right? Like we talked about the exchange attack. That's API is the initial attack vector, and then it has to kind of move down the stack, right, to the server infrastructure, lower level operating system. Those attack chains are incredibly complex. That's not typically the scope of expertise for your one-off attacker, right? You're talking about groups of hacker individuals. I did talk about this briefly, but the just to give you a visual example, there's actually two, right? There's this is actually a screenshot within the SALT API protection platform. If you haven't seen API endpoints, I'd say don't get scared by it. The thing that's really worth highlighting is over here, right? So this was actually an example on one endpoint where the Swagger, API specification only defined 2 parameters, but when they put SALT in place, they actually identified 27 parameters, right? And this is what I was saying, like identifying sensitive data, it's a problem because what you think you're building is likely much different, right, than what actually ends up in production. And this is that other problem I was talking about, right? The formats of those parameters aren't explicit. It's just a generic string. It doesn't tell you how many characters should it be, what's acceptable, what's the length. So not incredibly useful for discovery or protection. This one's really common. I'd say most of the time that we set up the platform, organizations are really surprised by how many more APIs they have than they initially thought, or parameters within those APIs. All right, it gets very complex quick. Those application traffic cops we were talking about earlier, I did allude to this, right? They're inline. Inline kind of infers proxy, right? And if you talk to an infrastructure or a network engineer, they get annoyed by reverse proxies, right? Or forward proxies. Like how many proxies do you start introducing into the infrastructure? Creates a lot of complexity. It's hard to troubleshoot things. Application engineers hate it also because it's going to start to add latency. It's also a problem for things like traffic inspection, right? When you talk about TLS intercept or TLS termination. So the more proxies you start to add, the worse things get. It certainly really impedes API performance. They're dependent on static rules. I mentioned that also. I don't have a visual example here, but I'd imagine many of you are probably familiar with like the age-old SQL injection example of like a single tick, right? That you probably flag that as a malicious character. That can actually break some API integrations, unfortunately. Like, what if you're dependent on the single tick? So in some cases, organizations actually disable those. But those are typically the kinds of like threat protection filters that are often marketed as. It's that basic, right? It's just going to flag on a certain character and then likely drop that request. We talked about how they're not built for business logic attacks, right? They need to be looking for these known malicious character sets. They don't understand business logic. It's not what they were designed for. We've also seen where API management itself is vulnerable, right? Because those API management suites, not necessarily Apogee, but some other products that were off the shelf, they are, those developer portals are web applications themselves. And then they work with backend database systems to power the whole thing. That web front end or the database backend might also be vulnerable. It's another application, right? So, typically the way organizations architect is the front end, their API gateways with a WAF. Apogee might tell you don't have to do that. That's a separate discussion, but many organizations do that because they recognize that it's yet another web app they have to protect. And we talked about this again with the statistics, right? Attackers regularly bypass access controls and they harvest API keys. There's a lot of research out there now. I believe Alyssa Knight's kind of tearing apart some mobile apps. This is really pervasive, right? And it can very quickly get into mobile app security. But developers will often hard code API keys into client apps because it's really hard to kind of create that authenticated session dynamically. And we were talking about this also, like authentication and authorization they seem easy at face value, but once you start talking about machines, in this case, a client app, how does that thing automatically create an authenticated session, right? It's not something a user, you would want them to approve. So yeah, this happens all the time. Tools to extract API keys from mobile application packages are really prominent. It's trivial to pull those things out, and they're often static. So they'll work today, they might work 2 years from now. The other thing I would say is, attackers will steal sessions. They'll steal your authentication cookies by compromising the endpoint. There's a really large spectrum of ways somebody could compromise an authenticated session. So where do we go from here? And Matt, keep me honest if I'm going too long on time.
You've got about 7 or 8 minutes, and,
okay.
and then certainly any questions that may come up in the chat there. I have one.
Yeah.
When we think about the proverbial OWASP top 10, can you kind of describe how long in the tooth it is in terms of addressing some of the more sophisticated and frankly effective application and security attacks that are occurring, or API attacks that are occurring?
And my question to you would be, which top 10?
Exactly. Because I think we hear things like cross-site scripting, session hijacking, SQL injection, and those types of concerns. But realistically, where the attack surface is fundamentally at different areas now. That there's been a notable commensurate change in adversarial behavior in terms of how our applications are being exploited these days.
Mm-hmm. Yeah, it's a really good question. My mindset is always the API is the thing of value, right? Even go back to when I was Verizon days, like I would test a mobile app and it's like, I didn't really care about the mobile app. Like, well, okay, you made this cool user experience. This is how the user interface worked. I didn't necessarily use the app. I would hook that into a proxy, see what the network traffic calls look like, pick apart the code to understand how the backend APIs work. And that's exactly how attackers work also. So if you're going to protect one thing, start with those APIs. And there are multiple OWASP top 10 lists. The one we promote heavily is the OWASP API security top 10. The application security one, I would say, was okay. It started to get like buckets of things that were hard to quantify, right? And if you kind of squint a little, many issues can start to fit into that. So it's like, how helpful is this? Issues like cross-site scripting aren't necessarily exploitable in an API either, right? So like a cross-site scripting attack, that's going to vary based on it. Like, is that useful to an attacker? It depends what the front end is going to do with that. Like, does it actually execute and render code? So injecting scriptable elements into an API call isn't necessarily the end of the day. That's much more kind of front end code or a mobile app issue. And actually, I think the OWASP mobile top 10 talks about that concept of hard coding things in the binaries, like I mentioned. So they're all relevant. You know, if you need a starting point for like how should you build up your security requirements, by all means, you use them all. But I would just say that the API is definitely your most valuable asset. All right, so let me try to go through this quick because I do want to try to save time for questions if we have them. My first recommendation is prioritize your use cases for API security. These are 8. Salt just happens to satisfy all of them. These are the most common that we've seen in customers, and it varies per industry. You know, the one on the top right, account takeover. We actually just put out some research that talks about credential stuffing and account takeover. That one's, you know, crosses verticals, but financial particularly cares about that, right? Because it actually feeds into that statistic again, right? A lot of attacks actually occur against authenticated APIs. It was like 94%. If I can get your credential, I don't care if you have an access control in place. I'm just going to use a credential to get into the app or data. Sensitive data exposure tends to, I'd say, appeal more to compliance and risk teams, right? Because they have to get a handle on where is all my data. I have to answer to auditors and regulators. So, you know, these are different business drivers for an organization seeking out an API security platform. It's going to vary, you know, based on your risk concerns, but they're all important. Things to look for, you know, if you are looking into an API security offering, you know, I'm going to do a pitch on Salt here briefly, so please bear with me. The reality is this starts to become like a data analytics problem, right? Because we talked about the limitations of testing tools. You can only test so much. Eventually, code starts to become very unique to your organization. How people consume the APIs is unique, right? It's going to depend on like your partner, your ecosystem, and the entire digital supply chain. So it becomes a data analytics problem because you have to gather all this telemetry and then you have to analyze it, right? So you need machine assistance for that. You know, the buzzword, right, is big data, right? You need cloud storage or elastic storage, and then you need machine learning to kind of analyze all of that data to unearth meaningful patterns. Deployment is incredibly important, right? Because we talked about that issue with proxies. If you're looking at an offering, it really needs to have kind of flexible deployment options because architectures they're like snowflakes, right? Everybody's doing something a little different. It's going to be a factor of, you know, your business and what you need to do. It has to integrate with existing workflows, right? This is what supports those DevOps principles, right? If you're forcing somebody to kind of learn a new tool, you've already lost, right? There's many CISOs we talk to that are like, don't sell me another thing. Like, if my engineers can't work with this, I don't even care. So talk to them, make sure they like it, make sure it works in their day-to-day tools. I don't need another, you know, security single pane of glass. So my quick Salt pitch, you know, I mentioned we have the complete coverage, right? We cover all types of architectures, including things like Kubernetes and service meshes if you are in that world, but also, you know, kind of legacy architectures with API gateways and load balancers. And maybe they're on-prem, maybe they're in the cloud, right? Maybe you're using AWS Elastic load balancers, but you have to support it all, right? Because architectures are distributed. We talked about that big data concept, right? That's how the Salt platform is built. So all that data is pulled in, analyzed. We call that our context-based API analysis architecture, or C3A. That feeds the platform, which can be consumed as a SaaS, right? You don't necessarily have to deploy a piece of software. Some of our customers do, right? That'd probably be another tech demo. If anybody's interested, we could certainly do that at some point. But there's different deployment patterns. So the console provides those kind of use cases I talked about, right? Maybe I need to discover my APIs. If I'm more in the SecOps role, I want to stop attacks and, you know about those things quickly. And if I'm in development and infrastructure roles, I want to fix things, right? I have to remediate, kind of work within that feedback loop with security and development. And this kind of just repeats what I was saying. I talked about the OWASP API security top 10. We do meet it. Some of our competitors do not. And it's basically because of how they've been designed, right? They might have been built as schema analyzers or micro firewalls, right? There's different ways competitors have built themselves. But this, the SALT security API protection platform is this thing in front of you. If you do want more information, the link's there. Definitely take a look. Got one more recommendation slide. So I talked about those application traffic cops. API mediation, there's a lot of non-security benefits to that anyway, right? So API mediation is something you'd likely be doing anyway. But if you are concerned about API security, look to augment further, right? We talked about how API gateways and API management can only do so much. They should be viewed primarily as like business enablers and access control enforcement points. We talked quite a bit about the security testing pitfalls. Yes, you should do it, right? Because in some cases, auditors might be asking those questions more and more. There is value in it, right? You can catch kind of those low-hanging fruit in a sense. We didn't talk about things like software composition analysis. So if you're using open source componentry that's known vulnerable, those are things you could very quickly test for, and do not put that in your code base. So there's value in it, but we talked about how you have to look at things in runtime as well. I'm not going to reiterate the API security offering, but if you do, want to look at them, I strongly encourage you to kind of look for something that's going to evaluate your business logic, because that is extremely unique. That gets into how your apps are, your app teams are designing and coding and integrating APIs. And the workflow, again, right? That it's all about DevOps or DevSecOps, depending on your perspective. But that's what kind of is going to appease digital transformation initiatives. That's everybody's working in their tools and work streams. You don't want to be disruptive to that. And there's quite a bit of resources here. I mentioned this at the start, right? It's kind of my world of generating research and talking about it. And there's definitely much more to come. And I did mention that threat research. I'd say definitely take a look at that. It's interesting because it's contains many of the OWASP API security top 10 types of issues, but details business context, right? Like, why is this important? Like, how would this impact the business? So it's not just kind of a technical thing. Like they have broken authentication or authorization. And that's it for me. So do we have any? Thank you, everybody. Go ahead, man.
And Michael, this was phenomenal. I really appreciate this. I know our chapter really benefited from the discussion. There's if you want to take a moment, there's an excellent question around kind of the issue with cryptocurrencies and APIs and what there may be there. And you also reference, and this is a little bit new because it was one that's attributable to some API concerns, was the Peloton issue. Mm-hmm. And so I don't know if you want to maybe spend just a moment and talk about Peloton and then think about the nature and extent of API considerations as it relates to blockchain at all.
Yeah.